Now is the time for you to learn how to apply the determinants to solve the problems. The first applications of determinant is used to find the inverse of a matrix. For a 3 by 3 and above matrix, the formula to find the inverse is A inverse equivalent to 1 divided by determinant of A and multiply with the adjoint matrix of A. And the adjoint matrix of A is basically a transpose matrix of cofactors. In the previous lesson, we learned how to find the determinant based on the cofactor expansion. In this case, the matrix of cofactors is roughly the same. It's just that we don't multiply the entry here with the corresponding entry. So for this tree, the minor will be the 6, 3, negative 4, 0. So recall back from the previous lesson, we have to cover up the entries along with this row and along with this column. So the leftover matrix will be the 6, 3, minus 4 and 0, and the corresponding minor will be the determinant of this smaller matrix as well as the cofactor sign. So in this case, the sign associated with this entry is positive, and you continue with the second one. So the cofactor is negative. As you have learned in the previous lesson, the plus minus sign should be alternate together, and then the minor will be the one when you cover the entries along with the 2 here, the row here and the column here. So the leftover entries are 1, 2, 3, 0. So you have the minor here, and you do the same for the rest of all the entries here, and then you transpose it. So this will be your adjoint matrix of A. And to find the inverse is basically just substitute everything into the equations. So 1 over 64, which is the determinant which has been determined in previous lesson, and the adjoint matrix of A has been decided here. So you just need to plug everything and get the inverse matrix. Now this is another method to find the inverse of a matrix using the determinant, because everything here in this formula involves determinant. So this is obviously determinant, and adjoint matrix is a matrix of cofactors which is part of the determinant. And in the first lesson in the chapter 1, you have learned how to find the inverse of a matrix using the A you put together with the identity matrix, and you reduce it to identity matrix and A inverse. So these two methods, which method that you think is easier, and which do you think is faster and is less time consuming? Another application of determinant is used to solve the system of linear equations, which is using the Cramer's rule here. The formula to get the unknown, let's say the first unknown is x1, is basically determinant of a1 divided by determinant of a, and so on. So what is this new matrix of a1, a2 and a3? So let's take one example. Let's look at one example here. So you have a system of linear equations, and the matrix A, which is the coefficient of all the unknowns here, 1, negative 3, and negative 1, 0, 4, negative 2, and so on. For a new matrix A1, for the first unknown, which corresponding to the first column, you just need to substitute it with the vector B here. For the second matrix A2 corresponding to the second unknown, you just need to substitute the B in the second column here. The rest of the entries remain the same as the matrix A, and you do the same for the third new matrix A3. So you just need to find out the determinant of all these matrices, and you substitute into this equation to get the values for the unknowns. So this is another method to solve a system of linear equations using the Cramer's rule. And in chapter 1 as well, you have learned how to use the row operations, Gaussian elimination, to solve the system of linear equations. So which methods that you think is easier?